Hey everybody, it's Mr. Carr again. Today we're going to be looking at 3.3 day 2. We're going to continue our properties of logarithms. We're also going to introduce the idea of what's called the change of base formula. So let's first talk about these couple of examples. This is going to be backwards of what we initially did, which is condensing it down. So what do we mean by condensing it? So if you remember some of the properties, if you notice here, it's subtraction. This is the property we're going to apply. We're going to take the log base b of x minus the log base b of y will turn into the log base b of x over y. Okay, it's our quotient property here. So I'm recognizing that that's a subtraction problem, meaning it's going to come together eventually as a division problem. Everything else, I've got my exponent rule that could apply here and here. So I'm going to start with that. So I'm going to have the log base 4 of x to the 1/2 minus log base 4 of x minus 2 cubed. Now I can put this together as a division. So it's going to be log base 4 of x to the 1/2 over x minus 2 cubed. And there's not really anything else I can do with this one. There are two different types of expressions between x and x minus 2. If I really want to, I guess I could turn this into a square root symbol. Not that I need to do it, but it is equivalent. So we can just show that. That'll be equal to the square root of x over x minus 2 cubed, like that. Okay, so let's go on to the next one. We're going to condense this down. Again, I'm going to look at what operation we have in the middle. So this is going to be the log base b of x plus the log base b of y. It's going to be the same as taking the log base b of xy. So we're going to be able to multiply these together. But before I do that, let's go ahead and take care of these exponents here and here. So I can take the natural log of x plus 1 to the 5th power plus the natural log of x to the 6th power. This is now all going to turn into a multiplication problem. So we can take the natural log of, I'm just going to put in the front, x to the 6th times x plus 1 to the 5th. That's going to be a lot if I try to distribute that out. So I'm not going to worry about that at this point. Okay, so we've condensed it down. That's as far as we can go with this one. Okay, so change of base formula. If we are dealing with log base b of x, then we can always change it to any base we want as long as we are taking the log base a. So a is some other new value besides the original base number. So log base a of the x value, so that's this number right here, divided by the log base a of the b value. We are typically going to do this with our just normal logarithms. What I mean by that is this. Let's say I take the log base 2 of 12. Okay. So instead of evaluating this as log base 2 of 12, it's going to be easier for our calculators if we do log base 12, or sorry, log of 12 divided by log of 2. So we can turn it into this kind of a division problem now. Okay. So log of 12 over log of 2. And I can do any base number I want, technically. So if I wanted to, I could make these base 5s. I can make them base 12s if I really wanted to. But there's no point in doing that instead of I'm just going to make it log of 12 and log of 2 because any scientific calculator can handle that then. So let's take a look at that here. Log base 6 of 4. So we literally are just going to take this number here. This is what's going to go in the numerator. And then this will go in the denominator. So I'm going to change it to log of 4 divided by log of 6. And that's it. That's all I can do for this kind of a problem. Okay. I should say, it does say evaluate it. So I'm going to go ahead and plug that in my calculator now. Let's do that real fast. So when I do that, I can use just simple logarithms. I don't have to worry about having a base number with it too. So I do log of 4 divided by the log of 6. We are going to get 0.774. Okay, and let's go one more decimal place actually. Let's go 0.7737. Be a little bit better to see that. So again, what this means though too, because this is evaluating this, means if I take 6 raised to the 0.7737 power, that should be right about 4 for an answer. That's what we're showing with evaluating this log base 6 of 4 here. Okay, let's do it again with this one. So change of base here, log base 1/3 of 8. So this is the same as taking log of 8 divided by the log of 1/3. Okay, so I could get that in my calculator because it's all base 10. So log of 8 divided by the log of 1/3 is going to give me a negative 1.8928. So the negative number here is fine because, again, what this is stating is if I look at this, the exponential form is 1/3 raised to the negative 1.8929, or it's 8928 is going to come out as 8, which makes sense because that's just going to do the reciprocal of 1/3 to 3. 3 raised to that power is going to give you 3 raised to that positive power should come out to 8. Okay. So that is it for today. Okay. That's one quick example you want to try it on your own, but you can see that it's going to be 1/5. It's going to come out as a -2 here. But if you do change of base formula, that'd be log of 25 divided by the log of 1/5. And then plug that in your calculator, you should come out as a -2. Okay. So that's it for today. So again, we are condensing it and also applying our change of base formula. All right. Take care, everybody.